We don't need too many complex components, just a few common ones to build an induction heater that can burn red iron nails. Induction heater. Today we will assemble a simple induction heater based on zero voltage switching. These two ERF140 MOSFETs are the heart of the circuit, which are responsible for alternating conduction, converting 12-volt direct current to high-frequency AC, providing energy for the subsequent heating circuit. Note the pin direction should not be reversed. These are two 3.8 ohm inductors. Their function is high-frequency choke, preventing high-frequency signals from flowing back, and provide stable operating current for the MOSFET, ensuring the circuit does not interfere with the power supply. Now, solder the first 220 ohm resistor, which is connected to a MOSFET's ridge. To limit the driving current to prevent the ridge from being damaged or mechanical vibration. This is the basic measure to protect the switch tube. Then, solder the second 220 ohm resistor, symmetrically connected to the ridge of the other MOSFET. The two resistors together form a gate drive protection circuit. To ensure both switch tubes can work stably, next install two UF4007 ultra-fast recovery diodes. They are connected in reverse parallel to the MOSFET's key node. To absorb the reverse peak voltage generated in the circuit, preventing the switch tubes from being broken. They are key components to improve reliability. Now, solder for capacitors of 0.33 microfarads. High voltage capacitors with a withstand voltage of 1200 volts. They are connected in parallel. Will form an LC resonant circuit with the heating coil. These four capacitors are responsible for storing and releasing energy, generating a high-frequency alternating magnetic field. High voltage withstanded is to cope with the high voltage spikes generated by tilt. Finally, connect the 13-turn disc-shaped heating coil. It forms a parallel resonance circuit with four capacitors. When the MOSFET driving circuit works, high-frequency current flows through the coil, generating a high-frequency alternating magnetic field. When a metal object is placed above the coil, eddy currents will be generated inside and heat up quickly after the circuit is initially completed. We use a screwdriver to conduct a vibration test. We bring the screwdriver close to the coil and wait for a moment. We can clearly see that the screwdriver has turned red and hot, indicating that the circuit has successfully oscillated. The circuit is working normally. Finally, we use an iron pot to verify the heating effect. Place the iron pot above the coil. Due to the ferromagnetic and resistivity of the iron pot, the snail quickly generates heat in the pot. In just a few seconds, the bottom of the pot can reach a significant high temperature. It verifies the practical function of this 12-volt induction heating system.